So in grade 11, when we learned the inverse and the reciprocal, we actually kept them in separate units. They should have been in the same unit because they're both dealing with functions, but to stop people from getting confused, we kept them separate. Now we're going to be looking at them together. So the inverse means switch x and y. The reciprocal function means to take 1 over your y value or take the reciprocal of it. So if I have a function that takes an x and sends it to y, the reciprocal function, which is denoted by 1 over f at x, there's no short form for that. You have to write 1 over f at x if you're dealing with the reciprocal, takes x and sends it to 1 over y, so the reciprocal of the height. Because we're looking at 1 over, we're going to have asymptotes, because anywhere where the original had a height of 0, 1 over 0 is undefined, therefore we will have an asymptote. We're going to have consistent points, because the reciprocal of positive 1 is 1 over 1, which is still positive 1. The reciprocal of negative 1 is 1 over negative 1, which still equals negative 1. So by consistent points, we literally mean they will not change. And then there's this relationship called inverse variation. What that means is as the original gets bigger and bigger and bigger, 1 over bigger and bigger and bigger numbers get smaller and smaller and smaller. So as one goes up, the other goes down, and vice versa. If I do 1 over smaller and smaller and smaller numbers, I get bigger and bigger and bigger answers. So inverse variation, when I teach it in grade 11, so that it's catchy and easy to remember, I do asymptotes, consistent points, swoop, because we're going to swoop in the opposite direction of the original. So we're going to start with a line, y equals x minus 2. We're going to sketch both, meaning the original function and the asymptote, and we're going to give the domain and range of both. So my first one is just a line. So it's y-intercept at negative 2, and my slope is 1 over 1. So here's my original x minus 2. Now I'm going to work through my 3 steps in order to come up with the graph of the reciprocal. So the first step is asymptotes wherever y equals 0. So right there, the original has a height of 0, and I can't take the reciprocal of that point, so I have an asymptote, and that's going to impact my domain and range later. Then I'm going to look at a height of positive 1, scan across, and put a dot on my graph. I'm going to repeat that at a height of negative 1, and I'm going to put a dot on my graph. Now I'm going to use inverse variation to fill in the shape, but that's where the swoop is going to come. As I move right from this point, my original goes up, I'm going to go down. I can never cross or touch the x-axis though, because 1 over x minus 2, because that's what I'm doing if I'm doing the reciprocal, can never equal 0 because the numerator is always 1. And these are all positive numbers, and 1 over a positive will always be a positive. Here, as I move towards the asymptote, the original goes down, so I'm going to swoop up. Over here, that's going to swoop down like that, that's going to swoop up like that, never crossing or touching the x-axis. And again, this should be review from grade 11. So this is the reciprocal graph, or 1 over my original. If I look at domain and range, well, the original one was just a straight line, and it wasn't horizontal or vertical. So the domain and range is XER, YER. Now this is not the inverse. I just can't switch them. I have to actually look at my graph or think about what's happening in order to get the domain and range of this reciprocal. My domain, it goes all the way left and all the way right, but it can't touch positive 2. So it's going to be everything except positive 2, so x naught 2. My range goes all the way up and it goes all the way down, but it does not touch this x-axis. So it has to say y naught 0. So you can't just look at the original domain and range to get your domain and range of the reciprocal. I could look at the original question and tell you x is not going to be able to be 2 because 2 minus 2 would give me 0, and I can't reciprocate 0. And then I know reciprocals are always 1 over, so I know you can never get 0 because you always have a numerator of 1. So I anticipated those, but they can be verified or found using the graph. One more example, looking at a quadratic. And this one doesn't talk about the reciprocal, but it asks us to sketch something that looks like a reciprocal. 1 over x squared minus 4. I don't know how to graph 1 over something directly, so I'm going to pretend that I just have the bottom. So I'm going to look at y equals x squared minus 4. This is a parabola with the vertex of 0, because there's nothing in the bracket, -4. It opens up in its normal pattern because it's a positive 1 in front of my x squared. So I'm going to start, even though it didn't talk about reciprocals, the graph they're asking me to graph looks like a reciprocal. So if I graph it, I end up with something that looks like that. So they've never asked me to graph x squared minus 4, but because that was the function on the bottom, I started with that. Now I'm going to go through my 3 steps for the reciprocal. Asymptotes, consistent points, swoop. So I have an asymptote at -2 and an asymptote at +2. If they asked for the equations of the asymptote, they would be at x equal to positive or -2. They are vertical lines, and vertical lines always have the equation x equals. Now I'm going to do my consistent points, and sometimes it gets tricky with quadratics because everything is quite squishy, but I scanned across at +1 and I put my dots. I scanned across at -1 and I put my dots. Now I'm going to fill in using my inverse variation as best I can because it's very squishy. And then I have something happening here. Here, this goes up, so I go down. They're always going to separate from each other when you do that. That goes up, so I go down, but I have a whole bunch of stuff that's happening here in the middle. That's where I take my lowest point, which is at -4. The reciprocal of -4 is 1 over -4, or -1/4, or -0.25. So that's going to be very, very close to the x-axis, but it's not quite going to touch it. So that would be the graph, the green one, of g at x as 1 over x squared minus 4. Even though the question said nothing about reciprocals, because the equation was 1 over, I chose to graph the bottom and then do 1 over the bottom using the reciprocal method to get my graph. If they ask me for domain and range, domain is everything except positive or -2. The graph's going to go all the way this way, all the way in the middle, and all the way to the right, and jump over those 2 numbers. The range a little bit trickier here. In grade 11, I let you just kind of say y not equal to 0 for most reciprocals, and that's because that's the case. But here I have a little bit more happening. I have y greater than 0 or y less than -1/4, because technically there is a tiny little gap in the graph between this highest point on the negative side, which is at -1/4, and then it jumps to the positives. So I have a whole gap in between 0 and -1/4, so I'm only bigger than 0 or less than -1/4, but nothing in between. So for this, and again, this should be reviewed from grade 11, on page 409, you can look at questions 1 to 6. Email me any questions. The nice thing is you can pause the video and talk about the video and your questions or the homework, and I will see you on Monday.